This is SpaceTime Series 23, Episode 91. Coming up on SpaceTime, looking at the end of the universe, the Pentagon planning a shooting star military space station, and NASA to begin operational commercial crew flights next month. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study claims the universe won't end with a bang, but with a whimper, facing a heat death from a black dwarf supernova. Ever since the end of the cosmic dark ages and the epoch of reionization, a few 100 million years after the Big Bang 13.8 billion years ago, the universe has been going through what astronomers call the Stelliferous Age, with the birth, life and death of stars dominating the cosmos. Massive stars do a sort of James Dean act, living fast and dying young, burning through their nuclear fuel supplies in just a few tens of millions of years, and then exploding as supernova, and depending on their mass, becoming either black holes or slowly cooling neutron stars. Smaller stars like our Sun will live a lot longer, around 12 billion years before running out of fuel, puffing off their outer envelopes as planetary nebulae and exposing their white-hot stellar cores as white dwarves, which will then slowly cool over the eons of time, eventually, in a few trillion years' time, becoming black dwarves. And there are some stars known as red dwarfs, spectral type M stars to be precise, which just happen to be the most common types of stars in the universe, and which have the lowest mass. They're burning through their nuclear fuel supplies so slowly that no red dwarf that has ever existed has yet died by running out of fuel. Of course, eventually, even red dwarfs will run out of fuel and die. The death of stars is what astronomers refer to as the so-called heat death of the universe. It'll happen when all that's left in the cosmos are black holes and burnt-out stars in a cold, dark, never-ending emptiness. But now, a report in the monthly notices of the Royal Astronomical Society and on the pre-press physics website archive.org has come up with a new picture, based on how these dead stars might change over the eons. Punctuating the darkness could be silent fireworks, explosions of the remnants of stars that were never supposed to explode. It all comes about because of new theoretical work suggesting that many white dwarfs may explode in supernovae in the distant far future, long after everything else in the universe has died and gone quiet. The study's author, Assistant Professor Matt Kaplan from Illinois State University, says that as white dwarfs cool down over the next few trillion years, they'll grow gradually dimmer and dimmer, eventually freezing solid and becoming black dwarfs, stars that no longer shine. But like white dwarfs today, black dwarfs will be made mostly of light elements like carbon and oxygen, and they'll still contain as much mass as the Sun, and it will still be compacted down into superdense objects the size of the Earth, which is also the fate to befall the Sun. But this is where it gets interesting. Kaplan says that just because they're cold doesn't mean nuclear reactions stop. He postulates that fusion reactions can still happen in these dead stars because of something known as quantum tunneling. Now, in its simplest terms, quantum tunneling is the idea that in the quantum world of probabilities, there's always a possibility, however so slight, that you could walk through a solid wall. Now, those chances are very low, but theoretically, in the quantum world, it could happen. And while that may all seem really far-fetched on the human scale, quantum tunneling in fact does happen on the atomic and subatomic scale. After all, that's how semiconductors, transistors and diodes work. And on the larger scale, it happens in the Sun as well. The Sun wouldn't shine without it, because it allows a minutely small number of protons, just 1 in 10 to the power of 28, to overcome their mutual electrostatic repulsion and provide fusion. And this isn't just happening because of the 15 million degree temperatures at the Sun's core. Kaplan says fusion due to quantum tunneling even happens at 0 degrees. Just that it would really take a long time, but ultimately it would turn black dwarfs into iron, triggering a supernova. Kaplan says that if he's right, it would mean black dwarf supernovae would be the last interesting thing to happen in the universe. But it won't be soon. It calculates it would take 10 to the power of 1100 years for these nuclear reactions to produce enough iron to trigger a 1.4 solar mass black dwarf to go supernova. 1.4 solar mass is important because that's the Chandrasekhar limit. And in case you're wondering, 10 to the power of 1100 is equivalent to saying the word trillion about 100 times. Now, of course, the most massive black dwarfs would explode first, followed by progressively less massive ones, until there are no more black dwarfs large enough left to go off, which Kaplan calculates would be in about 10 to the power of 32,000 years. Of course, that wouldn't be the end of the universe. Dark energy is causing the expansion of spacetime to accelerate, and depending on the strength of dark energy, the universe will ultimately either end in a big freeze or a big rip. A big freeze would see spacetime expand until all the galaxies, or at least all the local groups of galaxies, would be so far away from each other they'd be beyond the cosmic event horizon, meaning light from one galaxy or one local group of galaxies would never be able to reach another, which would mean a very cold, dark, black and empty universe. A more extreme version of dark energy, known as phantom energy, would see the forces involved increase by so much that it would eventually lead to a big rip, which would see the expansion of spacetime occur not just on the cosmic scale, but also on the subatomic scale, ripping apart atoms into the constituent protons, neutrons and electrons, and even overcoming gluons to rip off quarks. Ultimately, that would leave the universe with a vast, extremely thinly dispersed sea of quarks. Of course, that's assuming quarks can't be ripped apart into the constituent superstrings. This is space-time. Still to come, the Pentagon looking at using Sierra Nevada's Shooting Star cargo module as the basis for a new military space station. And NASA to begin operational commercial crew flights next month. All that and more coming up on Space-Time. The Pentagon is looking at using Sierra Nevada's Shooting Star cargo module as the basis for a military space station. The cone-shaped Shooting Star is a pressurized cargo module designed to be attached behind Sierra Nevada's Dream Chaser spaceplane. It'll provide additional cargo capacity for resupply missions to the International Space Station. But the 5-meter-long module isn't just an add-on. It's designed to be able to move autonomously using 6 thrusters. It's equipped with 2 large solar arrays developing 6 kilowatts of onboard power, and it can carry up to 4.5 tons of supplies. Current plans call for Dream Chaser and Shooting Star to begin supply missions to the International Space Station next year under NASA's Commercial Resupply Services program. The Dream Chaser Shooting Star will fly aboard the United Launch Alliance's new Vulcan Centaur rocket, which will be replacing the existing Atlas V family of launch vehicles. The Pentagon's initial plans would use the Shooting Star design as the basis of an autonomous unmanned space station for research and development, training and operational missions in low Earth orbit. Sierra Nevada would redesign the module to include guidance, navigation and control systems for sustained free-flight operations. It would host specialized payloads, undertake experimental testing, manufacturing and assembly in microgravity, and carry a range of logistics. Longer-term plans include higher elliptical and geosynchronous Earth orbits, as well as more distant lunar halo orbits, and even the possibility of including life support systems to allow the space stations to become manned. This is Space-Time. Still to come, NASA to begin operational commercial crew program flights next month. And September Skywatch, looking at the spring equinox south of the equator and the autumnal equinox in the northern hemisphere, as well as the annual Aurigids and Epsilon Perseids meteor showers. All that and more still to come on Space-Time. NASA's first operational commercial crew program flight to the International Space Station has been tentatively slated to launch on October the 23rd. The decision to go ahead with the SpaceX Crew 1 mission follows the successful completion of NASA's SpaceX Demo 2 test flight mission, which splashed down in the Gulf of Mexico on August the 2nd after a 2-month mission to the orbiting outpost. SpaceX Crew 1 marks the start of regular crew transfer flights to the International Space Station, in the process ending NASA's reliance on Russian Soyuz rockets, which have been the only means of getting there since the mothballing of NASA's Space Shuttle fleet in 2011. Crew 1 will launch aboard a Falcon 9 rocket from Pad 39A at the Kennedy Space Center at the Cape Canaveral Air Force Station in Florida. The Crew Dragon capsule to be used for the flight was transported from the SpaceX factory in Hawthorne, California last week and is now undergoing pre-flight processing. This initial mission will send a crew of 4, 3 from NASA and 1 from the Japanese Aerospace Exploration Agency, for a 6-month stay on station. They'll join the 3 Expedition 63 crew members already aboard the orbiting outpost, marking the start of regular 7-person crews aboard the space station. The Expedition 63 crew will then depart a few days later in their Soyuz MS-16 capsule and be replaced a week or so later by 3 new Expedition 64 crew members aboard the Soyuz MS-17. Meanwhile, NASA's already planning another multinational agency crew for their second operational commercial crew program flight, Crew 2. As well as 2 more NASA astronauts and another JAXA crew member, the mission, slated for April next year, will also carry an astronaut from the European Space Agency. This report from ESA TV.
European Space Agency astronaut Thomas Pesquet has been assigned to the second flight of SpaceX's Crew Dragon spacecraft, launching to the International Space Station in 2021.
Oh, it's great to be the first European to fly on a Crew Dragon. I flew on Soyuz before, very reliable, but now it's a completely different new vehicle, completely modern, and I'm very excited about it because it's a different approach to flying in space. Crew Dragon, it's big flat screens, the controls are very different from what you find in an aircraft, even a modern one, so it's really futuristic in a way, and that's exciting.
Thomas' second space mission will be called Alpha.
I chose to call my mission Alpha because my first one was Proxima, from Proxima Centauri, the star, the closest to the Earth, and this one is Alpha Centauri, so it's part of the same system. It's also close to the Earth, gives the idea of proximity with the people. What we do in space is for people on the ground. And also Alpha, to me, it's a Greek letter, so it's used very much in math, science, technology. It's also a symbol of what we do up there. Alpha is a symbol of excellence. It's the first letter of the alphabet. That's also, all the efforts that we do to achieve excellence in space. And finally, Alpha was also the name of the space station when it was developed at the beginning. And sometimes it's used as a call sign on a radio frequency communications. So that's why, to me, Alpha, it ticks all the boxes for being a really good mission name.
The Alpha patch was designed by ESA's graphic artists and features a rocket launch, the most dramatic moment in any space mission.
Around the patch, there's 17 colored slots, and they refer to the Sustainable Development Goals of the UN, which is a framework to try to achieve all the development goals around the world. So we're showing that what we do in space is actually part of a broader initiative to simply make the world a better place or make society better.
At the top, the International Space Station is stylized in the colors of the French flag. 10 stars sparkle in the background, evoking the Centaurus constellation and the number of French citizens who have flown to space. Thomas has already started training for his new spacecraft in the simulator and for his 6-month stay on the International Space Station.
I've been introduced to my new vehicle, the Crew Dragon, and we're building up our crew work in the sim, and I'm also preparing for everything that's going to happen on board the ISS, the spacewalks, the science, and managing all the systems of the space station.
Thomas' second mission promises to be action-packed as the space station crew increases from 6 to 7 members on average, and major upgrades are carried out to Europe's science lab in space.
And time now to turn our eyes to the skies and check out the heavens on September's Skywatch. September is the 7th month in the old Roman calendar, which had just 10 months before the addition of January and February. That 10-month year is still reflected today with the names September or Septem, Latin for 7, October or Octo meaning 8, November or Novem 9, and December or Deci meaning 10. It really wasn't until the Gregorian calendar that January 1st marked the start of the year. But in the beginning it was mostly only Catholic countries that adopted it. Protestant nations only gradually moved across, with the British, for example, not adopting the reformed calendar until 1752. Prior to that date, the British Empire and its American colonies still celebrated the new year on March the 25th. Highlight of the month is the September Equinox, which takes place this year at 23:30 on the evening of Tuesday, September the 22nd, Australian Eastern Standard Time. That's 9:30 in the morning US Eastern Daylight Time and 13:30 in the afternoon Greenwich Mean Time. The day marks the point in Earth's orbit around the Sun when the planet's rotational axial tilt means the Sun will appear to rise exactly due east and set exactly due west to someone standing on the equator. It means almost equal hours of darkness and light. In fact, the very word equinox is derived from the Latin, meaning equus or equal, and nox meaning night. It all comes about because Earth's rotational axis is tilted at an angle of about 23.4 degrees in relation to the ecliptic, the plane created by Earth's orbit around the Sun. Earth's axial tilt is pointed in the same direction in the sky, regardless of Earth's orbital position around the Sun. On other days of the year, either the northern or southern hemisphere are tilted more towards the Sun. But on the two equinoxes, usually around March the 21st and September 23rd, the tilt of Earth's axis is directly perpendicular to the Sun's rays. For those in the northern hemisphere, it means the start of fall or autumn, while those south of the equator are moving into spring. Okay, let's start our tour of the September night skies by looking to the east and to the constellation of Capricorn, the goat. The name comes from the ancient Greek tale of the demon Typhon emerging from a fissure in the earth and attacking Zeus, the king of the gods, during a banquet. Apparently, the flute-playing goat boy Pan, who was entertaining Zeus, became scared and tried to escape by turning into a fish and swimming away. However, he changed his mind before completing the transformation and instead distracted the demon by playing his flute. That gave Zeus enough time to use a thunderbolt from the heavens to frighten Typhon away. Because of his actions, both cowardly and brave, Zeus placed Pan in the sky forevermore, still in his half-goat, half-fish guise. The brightest star in Capricorn is Delta Capricorni, also known as Demi Balgeti, or the tail of the goat. It's located about 39 light-years away. A light-year is about 10 trillion kilometres, the distance a photon can travel in a year at the speed of light, which is about 300,000 kilometres per second in a vacuum and the ultimate speed limit of the universe. Demi Balgeti is a spectral type A white Beta Lyra variable eclipsing binary star, which means it's actually two stars closely orbiting each other. Astronomers describe stars in terms of spectral types, a classification system based on temperature and characteristics. The hottest, most massive and consequently most luminous stars are known as spectral type O blue stars. They're followed by spectral type B blue-white stars, then spectral type A white stars, spectral type F white yellowish stars, spectral type G yellow stars, that's where our Sun fits in by the way, then spectral type K orange stars, and the coolest and least massive stars known are spectral type M red stars. Each spectral classification is further subdivided using a numeric digit to represent temperature, with 0 being the hottest and 9 the coolest, and then a Roman numeral to represent luminosity. Now put all that together, and it means our Sun is classified as a G2V, or if you prefer G25, yellow dwarf star. Also included in the stellar classification system are spectral types L, T and Y, which are assigned to failed stars known as brown dwarfs, some of which were actually born as spectral type M red dwarf stars, but became brown dwarfs after losing some of their mass. Brown dwarfs fit into a category between the largest known planets, which are about 13 times the mass of Jupiter, and the smallest spectral type M red dwarf stars, which are about 75 to 80 times the mass of Jupiter, or less than a tenth the mass of the Sun. Now in the case of Demi Balgeti, as we said before, it's a Beta Lyra variable eclipsing binary. That means the total brightness of the system changes because the two component stars periodically pass in front of each other as seen from Earth. Therefore, one star blocks out some of the light coming from the other star in the system. The two component stars of Beta Lyra systems are massive giants or supergiants, so close to each other that their shapes have become heavily distorted by their mutual gravitational forces. It gives each star a sort of ellipsoidal shape, with extensive mass flows from one component to the other. like a rugby league or gridiron football. And because they're so close together, there's also extensive mass flow from one component to the other. Now, if you look just below Capricorn on the eastern horizon, you'll find the constellation Aquarius, the water carrier to the gods. Greek mythology describes Aquarius as the most stunning-looking youth that ever lived, and so was carried away from Earth up to Mount Olympus by Zeus in the guise of Aquila the eagle in order to become the water carrier. The two brightest stars in Aquarius are Alpha and Beta Aquarii, a pair of luminous yellow supergiants that were once massive spectral type B blue-white stars. The pair are moving through space perpendicular to the plane of the Milky Way. Beta Aquarii, the brightest of the pair, is also known as Tidalsud. It's a multiple star system located 540 light-years away. The primary star is about 6 times the mass of the Sun, but emits roughly 2,300 times the Sun's luminosity, implying a radius of at least 50 times that of our Sun. Beta Aquarii also appears to have 2 faint companion stars, but you'll need a decent-sized backyard telescope to see them. The second brightest star in Aquarius is Alpha Aquarii, also known as Saturn. It's located about 520 light-years away and is around 6.5 times the mass of the Sun, with about 3,000 times the Sun's luminosity. Next, we move to the southern constellation of Pisces Austrinus, the southern fish. The brightest star in the constellation is Fomalhaut, the mouth of the southern fish. It's also the 18th brightest star in the sky. Thousands of years ago, Fomalhaut used to mark the position of the winter solstice, the Sun's most southerly position. But over the years, the precession of the equinoxes has moved the northern winter solstice to its new position in December. The solstices and equinoxes change their calendar dates because of something called precession, which causes the Earth's spin axis to wobble ever so slightly, just like the axis of a spinning top. Now, that rate of precession is about 0.5 degree per century, so you won't notice it on the normal scale of a human lifetime. But because the direction of Earth's axis of rotation determines at which point in the Earth's orbit the seasons occur, precession will cause a particular season, for example the Southern Hemisphere summer, to occur at a slightly different place from year to year over a 21,000-year cycle. At the same time, Earth's orbit itself is subject to small changes, known as perturbations. Earth's orbit isn't circular but an ellipse, and there's a slow change in its orientation which gradually shifts the point of perihelion, Earth's closest orbital position to the Sun. These two effects, precession of the axis of rotation and the change in Earth's orbital orientation, work together to shift the seasons with respect to perihelion. And because we use a calendar year that aligns to the occurrence of the seasons, the date of perihelion gradually regresses through a complete 21,000-year cycle. Located nearby at just 25 light-years away, Fomalhaut is a spectral type A white-yellow star, about twice the mass of our Sun with about 16 times the Sun's luminosity. It's also a very young star, just 400 million years old compared to the Sun's 4.6 billion-year age. Fomalhaut also exhibits excess infrared radiation. That suggests that it's surrounded by a circumstellar disk of dust and gas. It's part of a triple-star system, together with a spectral type K orange dwarf star, TW Pisces Austrini, and a spectral type M red dwarf star, LP 876-10. Okay, turning to the north now, and we find the constellation Pegasus, the winged horse of Greek mythology. Pegasus was the one who delivered Medusa's head to Polydectes, after which he travelled to Mount Olympus in order to become the bearer of thunder and lightning for Zeus. The brightest star in Pegasus is the orange supergiant Epsilon Perseids, which marks the horse's muzzle. Almost 12 times the mass of the Sun, it's a spectral type K supergiant nearing the end of its life. Astronomers are still debating whether it will end its days as a core-collapsed supernova or a rare neon oxygen white dwarf. Also in the north is the constellation Cygnus the Swan, which lies right on the plane of the Milky Way galaxy. Cygnus contains the star Deneb, one of the brightest stars in the night sky, and one corner of the Summit Triangle. It's also home to the giant Cygnus OB2 stellar association, which includes NML Cygni, one of the largest known stars. A red hypergiant with about 1,183 times the radius and 50 times the mass of our Sun. If placed in the centre of our solar system, its surface would extend out past the orbit of Jupiter, and it contains a volume approximately 1.6 billion times that of the Sun. NML Cygni is located about 5,300 light-years away. Cygnus is also home to the now famous Cygnus X1, a powerful galactic X-ray source which became the first widely accepted black hole. It was discovered back in 1964 and remains among the most studied astronomical objects in the sky. This black hole is estimated to have about 14.8 times the mass of our Sun, all crammed into an event horizon with a radius of just 44 kilometres. Located just above the northern horizon this time of year is the star Vega, the brightest star in the constellation Lyra and the fifth brightest star in the night sky. Vega has about twice the mass of our Sun. It's a relatively young star, less than 500 million years old, and it's located fairly close by, just 25 light-years away. Now, because of the precession of Earth's rotational axis, Vega was the northern pole star around 14,000 years ago, and it will be again in around another 12,000 years. Now, just above Vega is Alpha Acri, or Altair, the brightest star in the constellation Aquila. It's another spectral type A white-yellow star with about twice the mass of our Sun. Altair is another nearby neighbour, located 16.7 light-years away. It rotates extremely rapidly, with an equatorial velocity of around 286 kilometres per second, which is a significant fraction of the star's estimated breakup speed of around 400 kilometres per second. Its high rate of rotation means Altair is not spherical, but flattened at the poles. In Greek mythology, Altair is the eye of the eagle which carried Aquarius up to Mount Olympus to become the water-bearer to the gods. Okay, turning to the southeast now, you'll see the star Achernar. It's the brightest star in the constellation Eridanus, the river. Located 140 light-years away, Achernar has around 7 times the mass and 3,000 times the luminosity of our Sun. The star rotates so rapidly it's elliptical in shape, with its equatorial diameter about 56% wider than its polar diameter. September also sees the bulk of the Aurigids meteor shower, produced as the Earth passes through the debris trail left behind by the comet KESS C1911N1, a long-period comet which only reaches the inner solar system every 1,800 to 2,000 years. This meteor shower runs between August the 28th and September the 5th. The Aurigids provides about 5 swift and bright meteors every hour, with its peak occurring just before dawn. It's best viewed from the northern hemisphere, as its radiant, that is the direction the meteors appear to be coming from, lies in the northern sky constellation of Central Auriga. The second meteor shower this month is the Epsilon Perseids, which run from September the 5th to the 21st. Although they're called the Epsilon Perseids, the radiant actually lies closer to the star Beta Perseus or Algol. Now, the Epsilon Perseids shouldn't be confused with last month's Perseids meteor shower, because while they both appear to have their radiant in the constellation Perseus, they're actually caused by the debris trails from 2 different comets. And now, with more of the September night skies, we're joined by Jonathan Nally, the editor of Australian Sky and Telescope magazine.
Well, let's start with the Milky Way and the constellation. Mid-evening, September, early September, you've got the Milky Way. That's our home galaxy seen from the inside, and it's stretching right across the sky from north to south. If you're anywhere dark, you're away from lights, skipping away from city lights, and you just look up, straight up in September, you're going to see the Milky Way straight going north and south. Really tremendous. Give your eyes a little time to dark adapt, keep away from lights and things, and the longer you can let your eyes adapt, about 20, 30 minutes, the more you'll see. So for those of us at sort of mid-latitudes in the southern hemisphere, with the Milky Way overhead, we've got the centre of our galaxy, the centre of the Milky Way, and you've got the star fields of Scorpius and Sagittarius. They're basically straight overhead. Really superb viewing, and with your eyes dark adapted and from a dark spot, you'll see that it's not just a mass of stars. You've got all these dark lanes of dust and stuff going through it as well. It really is quite incredible. I mean, it's an amazing sight, but when you think of what you're seeing, stars and stars and stars and big clouds of gas and dust, light years and hundreds of light years and thousands of light years away. You're seeing basically a 3D picture of our galaxy from the inside. It really is quite amazing.
How far away from the city does one need to be to see this?
You don't need to be too far. I mean, you don't have to go hundreds of miles away from the city. Just make sure you're 3 or 4 k's away from any street lights. Just get as far away from street lights as you can. Most of the light pollution that affects you is within a few k's, few kilometres of where you are. So if you can just get somewhere that's dark, there are places within suburbs that are fairly dark. Just get away from as many of the street lights as you can, and try and get them blocked from your direct vision. So stand behind a wall or behind a tree or something. Just get them.
You can get arrested for that.
Vision. You can get arrested for that. I know. What are you doing there, officer? I'm just looking at some heavenly bodies. Now, way down south, we've got the Southern Cross, It's lying on its right-hand side at this time of year in the sort of mid-evening or early evening. So it looks a bit like a kite, very small, and it's lying on its right-hand side at the moment. And above it, you've got the two pointer stars. Now, if you've got really dark skies and you've let your eyes adapt to the dark, see if you can see a dark patch just next to the Southern Cross. This is a huge cloud of dark dust and gas floating in space, and it's called the Coal Sac Nebula because it looks really black. You see it on photos, and it's like this big black blob sitting next to the Southern Cross with a few little stars in the middle of it, and those stars are in the foreground. They're between us in this big dark dust cloud.
Emu Nebula?
The Emu Nebula is an enormous thing that stretches halfway along the Milky Way. It's part of it. Yeah, it is. The Coal Sac is part of the Emu Nebula, but the Emu Nebula is really big. It's basically you join up all the dark nebulae along the length of the Milky Way, or part of the Milky Way at least, and then you can see this emu shape. I couldn't see it for years because I was looking for something small.
Yeah.
But it's actually really big, like a huge expanse, like 30, 40, 50 degrees of angle all the way across the sky. You join up all these dark nebulae, and yeah, you do see the shape of a sort of an emu with its neck outstretched upwards.
Cool.
It really is quite something to see, yeah. So use your imagination, you can see all sorts of things up there. Another thing that's near the Southern Cross is a little cluster of stars called the Jewel Box, which looks really, really pretty. If you get a pair of binoculars onto it, it'll show really well. It's really nice.
It's a little open cluster.
Yeah, it's a little open cluster, and it's really pretty because the stars, there are a few different coloured stars inside it, and they're quite condensed together. They're not really spread out very far. That's why it looks really good. It's just near one of the stars of the... If you look at the Southern Cross as it is at the moment, so it's lying on its right-hand side, then the star that would be the left-hand star, which at the moment is the sort of top star, if you just look a little bit to the up and to the left of that, you'll see this little... With the naked eye, you'll see a little fuzzy blob, and if you get a pair of binoculars, just any pair of binoculars onto it, and you'll see it's made up of little stars. And it's really, really pretty. It's called the Jewel Box, because they look really, really pretty. Now, as the night goes on and the Earth turns, the stars, of course, will all appear to move across the sky, which is just the Earth turning the other direction, of course. So you're going to have stars going down below the western horizon and others coming up in the east. The eastern part of the sky is going to seem pretty bare and dim for most of the evening and late evening, but come around about 1 o'clock in the morning, then our favourite constellation, Orion, will start to come up above the horizon. So if you're up after midnight, have a look out to the east and you'll start to see the stars of Orion coming up. Now, for astronomers, this is the sign that the summer months are on their way, at least for us in the southern hemisphere. For our friends in the north, it means winter's on the way for them. But for us down here, it's a great time of year for stargazing because in the evening you've got Sagittarius and the galactic centre up there overhead. And if you wait up till after midnight a little bit, you'll start to see the summer constellations beginning to appear in the early morning sky. So we get the best of both worlds, best of winter and best of summer coming along. Now, as for the planets, well, there are two that you won't be able to miss at all at the moment because it's Jupiter and Saturn, and they're right overhead. So if you're any sort of major city around Australia or New Zealand or that sort of latitude, they'll basically be directly overhead in the evening. You can't miss them. Jupiter and Saturn. Jupiter's big and bright and bold. Saturn's nearby. It's a little bit dimmer, but still very prominent. Have a look on the 25th of September, and you'll see Jupiter and the Moon really close together. That's going to look pretty spectacular. We've got the red planet, Mars, coming up over the eastern horizon shortly after 9 p.m. at the beginning of September, and by about 7:15, not long after sunset, at the end of September. Now, Mars is heading towards a really good viewing season next month in October.
Yes, it's also getting closer, isn't it?
Getting closer, yeah. So next month, October, we're going to have what's called opposition, when it's directly opposite the sun in the sky, which is a good time for viewing. And within about a week of that, we also get the closest approach of Mars. Closest approach, of course, means that it looks biggest, because the closer it is, the bigger it looks. So you put those sort of things together, and we're coming up to a really good Mars observing season. We've got the planet Venus. That's a morning object at the moment. It's shining nice and bright above the eastern horizon before dawn. I mentioned that you can't mistake Jupiter and Saturn. Well, you cannot mistake Venus because it is big and bright, and there's nothing like it in the sky, certainly not at the moment in the eastern morning pre-dawn sky, that's for sure. So if you're up and about early and you think, what on earth is that big bright white light out there in the east as the dawn is beginning? Well, that's the planet Venus. And that's Stuart. It's the sky for September.
That's Jonathan Nally, the editor of Australian Sky and Telescope magazine. And don't forget, if you're having trouble getting your copy of Australian Sky and Telescope magazine from your usual retailer because of the current lockdown and travel restrictions, you can always get a print or digital subscription and have the magazine delivered directly to your letterbox or inbox. Subscribing's easy. Just go to skyandtelescope.com.au. That's skyandtelescope.com.au, and you'll never be left in the dark again. And that's the show for now. SpaceTime is broadcast on Science Zone Radio by the National Science Foundation in Washington, D.C., and through both iHeartRadio and on TuneIn Radio. Or you can subscribe and download SpaceTime as a free podcast through Apple, Stitcher, Bytes.com, Pocket Casts, SoundCloud, Spotify, YouTube, Audio Boom, Podbeam, Android, Castbox, from spacetimewithstuartgary.com, or from your favorite download podcast provider. You can help support the show and the work we do by visiting the SpaceTime online shop and grabbing yourself a few goodies, or by becoming a SpaceTime patron, which gives you access to commercial-free double-episode versions of the show, as well as bonus audio content and other rewards. Just go to our Patreon page through spacetimewithstuartgary.com for all the details. If you want more SpaceTime, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, at SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to www.facebook.com/spacetime with Stuart Gary. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.